Okay, there is one more section of exercise number 3, and what we're going to do is we're going to replace the resistor with the diode and repeat Ohm's law measurements. So we don't have to unhook anything. We're going to keep the patch cords the way they are. All I'm going to do is replace that resistor with this little diode right here. Now a diode, let me show you. One of its little legs is longer than the other one. Do you see that? Okay, so the longer leg is the positive end, and there's also a notch on it. It's kind of hard to see it, but let's see if I can. Yeah, it's kind of hard to see. Anyway, what we're going to do is put the long end where the positive end is going, which is the right-hand side. So I'm going to replace the resistor with the LED. And it means I'm just going to hook on this to here and this to here. And I'm just going to leave it like that. We don't really need the resistor anymore. And that's all it is. Let's put it down so you can see it light up. All right, so first of all, I'm just going to make sure that, oh, it lit up. I increased the voltage and it lit up. So the LED does work. What happens is that a lot of times you pull an LED out of my bucket and the students that used it beforehand burned it out and they just threw it back in the bucket without, and not throwing it out. So I got bum LEDs in there, but this one is good. So what I'm doing is I'm using the DC power supply. I turn it back on. You heard me turn it back on. I do not touch any of the cords unless I turn out the power supply. Now I've got it hooked up, so I'm turning it back on again. What we want to do is repeat the steps we did for the resistor, but for an LED. And this is an example of a non-ohmic device. You can look it up in your lab theory section. This is, of course, a very common device used in a lot of everyday life. So let's go ahead and repeat what we did before. We're going to start out with, 0 volts. Well, everything reads 0 on 0 volts, but let's go up to half a volt. So what I'm doing is dialing up to half a volt. We can't go up very high for the LED. I don't want to burn it out, although some groups do burn things out. Okay, that's good enough. 0.531, and the current is virtually 0.002. Okay, 0.531 versus for the voltage, 0.002 for the amps. And that goes under the second data table for 3. It'll say light bulb or LED on it. So let's go move up to 1. That's good enough. 1.039. The current isn't going up. This is actually expected behavior in an LED. The current does not start running until you get past a certain threshold voltage. It has to do with the chemical makeup of the LED. It's made up of 2 different semiconductors that are doped, one with the positive charge and one with the negative charge. Okay, so now what we're going to do is move it up to, 1.5. Oh, I'm keep going. Wait a minute. Getting better, closer. Ooh. Hold on. Okay, that's good enough. 1.520. All right, the voltage 1.520, and still no current going through LED, and you can see the LED hasn't lit up yet. So there's a threshold voltage that all of a sudden the current will start cascading through. And let's see if we get that going up to 2 volts. It depends if it's silicon or germanium. All right, so let's do 2.077. Oh, look at that. Now it's starting to light up. So we had to get up past 2 volts, then it would light up. And notice now the current's running through it, 0.0185. See how it's flicking back and forth? So 0.0185. So, and we can see it's lit up. So now it'll just be brighter now. Move it up to 2.5. 2.517, that's good enough. And 0.048. So the current 0.048, okay, maybe 0.0485. And now, Okay, fine. 0.049, it usually doesn't drift that way. And we can see it's nice and bright, the LED. And again, the voltage is 2.518. All right, so let's go up just a couple more here. 2.93, 3.048, and we've got 0.090. Now, you can see in the instructions, we're not going to exceed 4 volts. So we're going to go up just a few more, but we're not going to go past 4. So we're going to, because I don't want to burn it out. These are quite cheap, but still. 3.517. Okay, 3.517. And now the current's getting pretty high, 0.122 amps. 0.122 amps. All right, just a wee bit more, and that'll be 4, and then we'll have to stop because we don't want to go anywhere above that. 4.003. I got pretty close that time. Oh, okay, 4.003 and 0.147. So now looking at your data table, so this is the second data table in number 3. It asks, is the LED ohmic? Why or why not? Well, you have to plot it first. You may have seen from the data that the current was 0 for most of the time, then it started to shoot up. Plot it out, and you'll find out that you won't be able to draw a straight line through the data points. It looks very different than the resistor. So here is an example of a non-ohmic device. Plot both V versus I for the resistor and the LED. So the resistor, you can actually find the slope because it's a straight line. However, plot this one and see what you see. And then if it's a straight line, then it's ohmic. If it's not, then it's not ohmic. I sort of already gave away the answer because it's kind of hard not to tell you that when you're looking at the data as it goes on. Okay, so that's the end of exercise 3. That's actually part B of exercise 3. Okay.